Hey guys, the objective of this video is to look at the Mohr-Coulomb failure criteria, and we're going to be looking at effective stress. We're going to be looking at principal stresses once again. We're going to be talking about the deviator stress, and then we're going to have to look at how we go from total to effective stress on a Mohrs circle. So the failure criterion and this is for effective. You will normally be most of the time using effective and not total when it comes to these types of questions. So the formula is sigma 1 dash equals n subscript phi on sigma 3 dash plus 2c dash square root of n subscript phi, where n subscript phi equals 1 plus sine phi dash on 1 minus sine phi dash. So as you can see, just like the other formula where tau equaled c dash plus sigma n dash tan phi dash, we're relating the principal stresses. Now we're relating them to the cohesion and the frictional angle. So these equations are pretty much saying very similar things, where one is relating this one's relating principal stresses now to friction angles and cohesion, whereas this one is relating the actual stress, the normal and shear stress at the plane of failure. They're different because, once again, the triaxial test gives us principal stresses, which is sigma 1 and sigma 3, whereas the triaxial tests give us the shear and normal stress on the plane we're looking at. So that is the failure criterion, and we will normally be using effective. We need to now talk about the principal stresses and deviator stress. So we saw in the previous video that we had a cylinder of soil, and we, at the first stage, put on a radial stress, which was due to water pressure, and then we put on a force which acted over an area, which meant that we had a axial stress where sigma A, to get vertical equilibrium, sigma A equals sigma R plus F over A, where that is the force over the area, which gives us a stress. So what we can do is define these terms. The way they're defined is that sigma A is equal to the axial stress, which equals sigma 1. So this is one of our principal stresses. Sigma R equals the radial stress, which equals something known as the cell pressure, which makes sense because our entire cell is under a pressure of sigma R from the water, and this is equal to sigma 3. So we have our two principal stresses in terms of our radial and axial stress. Just to clarify, the cell pressure, the water, it's not the water in the soil, it's water that we're putting outside the soil sample, and we're putting that under pressure to create pressure on our sample. So here are our two principal stresses, and we can better visualize them now as our axial stress and our radial stresses. Another important thing is that from this formula we could rearrange this to get sigma A minus sigma R equals F on A. This F on A term we call Q, which is known as the deviator stress. So sometimes in a question you could just be given the deviator stress. All it is sigma A minus sigma R, and we know sigma A is sigma 1, and we know sigma R is sigma 3. So we can write this equation here, where sigma 1 minus sigma 3 is equal to the deviator stress. Once again, it's just a convention where they could maybe give you the deviator stress in a question, and you would be able to use that. And the final thing we need to talk about is going from total to effective stress on Mohrs circle. So as you can see, our failure criterion is in terms of effective stress, but the stresses subjected on our soil sample are in total stress. Sigma R and sigma A are total stresses. So if we were to draw, so before we even draw, we know that the total stress, so we saw before that the total stress equals the effective stress plus the pore water pressure. So what we can write is, in terms of our principal stresses, we can say that sigma 1 equals sigma 1 dash plus U, which we can rearrange to get sigma 1 dash equals sigma 1 minus U, where U is the pore water pressure at failure. So that would normally be given to you. So you could get from total stress to effective stress, which is what we need to use for our failure criterion. So we have that sigma 1 dash equals sigma 1 minus the pore water pressure at failure, and similarly sigma 3 dash equals sigma 3 minus the pore water pressure at failure. We could also write this, if we really wanted to, as sigma A dash, which equals sigma R dash. But you're mainly using 1 and 3. So visually what this means on our Mohrs circle is if we were to have our axes here, and we were to have our Mohrs circle like this. I'm just going to draw the top half, we don't need to really worry about the bottom half because it's symmetrical. So we would have sigma 3 and sigma 1, which we know is the same as sigma 3 is the same as sigma R, and sigma 1 is the same as sigma A. Now what we want to do is, because our failure criterion is in terms of effective stress, we'd have to draw a new Mohrs circle like this, where this is sigma 1 dash, and all we've done is, this is sigma 3 dash, where all we've done is we've subtracted off the pore water pressure. So we've gone from sigma 3 to sigma 1 dash, we've just subtracted U. Okay, so we've just shifted our circle, that's all we're doing. Where similarly, this would be sigma 1 dash, and all we've done is we've subtracted U. So we can see from our formula, sigma 1 dash equals sigma 1 minus U. Graphically, that means that, this is sigma 3, no, it's all good, okay? So sigma 1 dash equals sigma 1 minus U. So sigma 1 dash equals sigma 1 minus U. So we've shifted our circle to here. And sigma 3 dash equals sigma 3 minus U, as given by the effective stress formula. So this circle gives us our principal stresses in terms of the total stress, and this one gives us the principals in terms of the effective stresses. So all these concepts we're going to be using in the next video, where we're going to be doing an example. It seems like a lot of ideas you need to know at this point, but they all come into play, and it might seem very disorientated at the moment, but I would recommend looking at the next video where we're going to be doing an example, where we're going to be constructing a Mohrs circle and using this fail criterion to find the properties of the soil. Hope that helps, guys.